Then we had substitution reactions. There is when something substitutes, and I said there we must be careful. It must be mild. So you can't have a lot of heat. It must be mild heat. If you have a strong base or an acid, it must be diluted or dissolved in water. Then we are busy with addition reaction. So that is where you add something. You can only add something if you start with a double bond. That is important. So you must start with a double bond or a triple bond, then you can add something. Now we did a few reactions here. We had hydrogenation, is where you add a hydrogen. You had halogenation, is where you add a halogen. Then we had halogenation, so where you add a hydrogen and a halogen. And then the last one that we have there, we didn't complete this one. The last one that we have there is hydration. Okay, let's continue with halogenation. So they say here we start with propene, ene for a double bond, pro for 3 carbons. Okay, you add, let me ask, Chichi, what is the name of this thing? Okay, it's hydrochloride, but what is the common name? It's an acid. No. It is hydrochloric acid. You've heard about that before? Yes, hydrochloric acid. Okay. Now, what I do with my product is I rewrite this thing exactly like I got it. So 3 carbons, and I fill in all my hydrogens, and then I say, okay, for addition, this double bond must break. If that double bond breaks, then you get a bond there and you get a bond there. Okay, now what will fit in there and there is a hydrogen and a chlorine. But where the hydrogen and the chlorine goes is very important. You can't just put anyone anywhere. For us to know where the chlorine goes and where the hydrogen goes, we have to follow, and this is where we had a lot of discussion and we lost the track, Markovnikov's rule, the Russian. Okay, his rule says that when you attach an H with something that is weird to a double bond, then the hydrogen attaches to the carbon with the majority of hydrogen or the most hydrogens. It's like you guys, when you go to an unfamiliar place, you look to see where is Patrijs people or where's people that you know, and you go there, right? Because you feel safe with people that you know. Okay, so the same thing here. You have a carbon with a hydrogen and a carbon with 2 hydrogens. So this hydrogen will go to the carbon with the most hydrogens. Okay, so there you will get a hydrogen and then the chlorine will go sit there. Okay, so when this reaction happens, then this we call the majority or the major product. And it does happen that the hydrogen goes sits there and the chlorine sits there. That we call the minority product or the minor product. Okay, but they don't ask that. They only ask the majority. So
the chloride goes to where there's more hydrogens?
No, the hydrogen goes to the one that has the most hydrogen. Okay, so Wutumelu, what is the name of this organic product? Jy moet ook dink.
Which one did you point it?
The organic product
Of what?
of this reaction.
Number 4. Number 4.
Yeah,
No, the number 4 at the bottom.
no, number 3, the one that we're busy with, the name of the product. Yes? Okay, almost where does the chlorine sit? Okay, so try again. Yes, 2-chloropropane. Okay, pro because there's 3 carbons. Ane because there's a double bond between the carbons. 2 for the second one. Say again.
said
Single.
Single bond.
You see
It's a
double bond.
covalent.
What did I say?
Double.
Oh, sorry.
Yeah, wait.
Okay, I'm glad.
Okay.
And 2, because on the second carbon you have a chloro. Remember, you do not put a dash in between there. Then it's wrong. You only have a dash between a number and a letter. Okay. And the next one is hydration. Okay, so like the word tells you, when you are dehydrated, you need water. So when you are hydrated, you add water. So hydration is when you add water. Now, I said at the beginning, I don't know if you remember, I said whenever from now on until the end of the trip, if we say hydrogen, you must think platinum must be there. Those two go together. Okay, the same thing with water and sulfuric acid goes together. Those two are friends. Okay. I still said if you think of Miss Marks, you think? You think physics? Okay. I in the Afrikaans classes said they think about tackies because I wear them every day. Okay, and it's true. It's the only shoes that fit my big feet at the moment. Alright.
Because it gets so
Heels.
pregnant.
Do you have them?
Oh, what was it to do with that?
No, like in general. In general.
Why did she ask?
Do I wear heels?
Do you have?
Do you
I
have?
own
Yeah.
heels.
Basically have.
No, they're just decorating in their closet.
Yes.
Ah.
See how far I must walk
Not when
upstairs.
you like, when you popped.
What did he win? Ah, no,
When you give it back.
I will come to school with heels once.
Yeah. But you understand? I didn't offend you, I know.
And, no, you didn't. All right. Okay, so those two go together. Water and sulfuric acid. Okay? So sulfuric acid here acts as a catalyst. And then no extra energy. So you don't need to heat it up or stir it or anything like that. Because addition reactions wants to happen. It happens spontaneously. Okay, so here we have butene. But means 4. And you can see there the general formula, or it fits this general formula, CnH2n, which means it belongs to the alkene functional group. Homology series. Yes? Something you studied? Okay, so we must have a double bond somewhere. And just to prove a point, I'm going to put the double bond on the first one. But I didn't specify here. It could have been on the second one as well. You fill in all of your hydrogens. You guys did this fairly well in the test. Well done. Okay. Right, now we want to show that sulfuric acid is a catalyst, a chemical thing that you add. You always put at the top of the arrow. At the bottom you add the physical thing like the flame or the whatever. Okay, then I'm going to...
You always add the one at the top.
The chemical thing that you add. Okay, so I redraw my reagent exactly like I got it. And now I say, all right, here something can be put in and there something can be put in. Okay, what needs to go there? We have an OH, an hydroxyl group, and an H. Tapelo, doesn't matter which one goes where. Yes, because they're different. Whose rule are we going to follow? Wait, Markovnikov's rule. And what does the rule say, Tapelo?
When there's a HX
Yeah.
to a double bond,
Nee man, think.
hydrogen attaches to the couple.
X can be either chlorine, bromine.
With the majority of hydrogens.
Yes. So the rule states that this hydrogen goes to the carbon that has the most hydrogens. You don't need to know this rule off by heart. Okay, you must just apply this rule. So don't go study this rule like a definition. You must just apply this rule. So this carbon has 2 hydrogens and this carbon has only 1. So we're going to put the hydrogen there and the OH there. Cananello, to which homologous series does the product belong to? Homologous series.
Isn't it alkene? No alcohol.
Yes, it is an alcohol. Then, Banele, is it a primary, secondary, or tertiary alcohol, and why?
Secondary,
Why?
because it's the dome product. Because the
No.
reagent is inside.
The product is a secondary alcohol. Why? It's not because it's second.
Ma'am, can I go to Oh, ma'am, it's because you see the 2 degrees.
2 degrees.
2 what? The 2. Yeah, that one.
This just means that it's secondary.
That is the second carbon.
Yeah. No. I stated this over and over and over.
It's 3 weeks and then do physics. That one.
The alcohol.
Lapelo.
Oh, ma'am.
The carbon that's connected to the
No, it's not connected. It's attached.
is attached to other carbons.
Yes. Not because it's second. If it was on this one, it would have also been secondary. So it's a secondary alcohol because the carbon attached to the OH is attached to 2 other carbons. Secondary, 2 carbons. If the OH was here, then it would have been a primary alcohol because then the carbon attached to the OH is attached to 1 carbon. Okay, now the people did you see my roof? Not my roof, my ceiling is painted, and they're on the outside as well. So if you complain over and over for 3 years, something else. Okay, but what I wanted to say is they stole all my sweets. Finito. That happens, eh? Anyway, Lepelo, not Lepelo, anyone. So for an IOU, sweetie, when I buy again, if this secondary alcohol oxidizes, to which homologous series does it change to?
Alcohol.
No, is it carbon?
The last one on the table. Alcohol.
Aldehyde.
I just said that.
Okay, now you have almost nothing left.
Here is no sugar.
It goes to a ketone. If it oxidizes, then that falls away. So this forms a double bond and it changes to a ketone. All right. Oh, sorry. Then I want the name of the product. Tabang?
Hey.
There's a butane.
The E is not right. It's A. Am I wrong? Am I wrong? The E is not correct. The M is another one.
Dankie, Tiamo. Say there? Yes, butane. Ein, because it's only single bonds, and butane, and then you must say where. Butane to all. Butanol. Alright, so now grade 12. Before we go on, we're going to start with your homework, and if we don't finish, then it's homework. Your homework will be page 29 and 30. 29 and 30. Okay, so we're going to start with 29. 30 is the same type of exercise. We must complete these reactions with structural formulas. Okay, so there we have pent 1 in. Pent is 5. So we have 1, 2, 3, 4, 5. And that's on the first one there is an in. On the first one there is a double bond. Okay, now I am going to be lazy. I'm not going to show every hydrogen. Okay, but remember in the test you must. I'm just going to show it like this. Okay, and then they say it is saturated with bromine. Okay, Lepelo, what does saturated mean? Yes, there's no double bonds or there's no multiple bonds. There's only single bonds. Okay, so when something is saturated, as you can see, you start here with a double bond. And then they say it's going to be saturated, there's going to be no double bonds at the end. So Miles, what type of reaction is that when you remove the double bonds? Say again?
Elimination.
We haven't even done elimination reactions. We've done oxidation, addition, substitution.
The last one we did. Substitution.
When you start with a double bond, it's always addition. Always, always, always addition. Tiamo, your question. What type of addition reaction is this? Page back, page back.
What kind of what?
What type of addition reaction? Look, what do we add? We add bromine.
Hello.
Yes.
What?
Hello, what?
Halogenation. So you don't add a hydrogen. So it's not a hydrohalogenation. You add only pure halogen. So it's halogenation. So I can ask you one of two questions. I can either ask you what type of reaction is this. Then you have a choice. You can either say addition or halogenation. Or I can ask what type of addition reaction is this. Then you must say halogenation.
So then, whatever this the addition, every definition, you add it with only this ones. You understand?
Yeah, I don't understand.
Yeah, you add with only this ones.
No, you can add
Halogenation.
you can add chlorine, fluorine. All right, then another question that I can ask Katlego is what is the reaction conditions for this reaction? The reaction conditions, meaning what must you add to this? Is there a catalyst? Is there heat? Is there something that you must add to it? Yeah, so you can say nothing. So if they say, and they can ask this, what is the reaction conditions? No conditions necessary or no extra heat added or anything like that.
Because it's saturated.
Say again?
Because it's saturated.
No, it's not saturated. It's unsaturated.
The product or the agent.
Yeah, but remember, reaction conditions is determined by the reagents. Why is there no reaction conditions? Because it is an addition reaction and in general they don't need extra energy. Okay, right. So,
All additions.
say again?
All additions.
Addition reactions, yes. Okay, so now you're going to write down your product. You're going to write down everything like it was given to you. But now your double bond is broken. It's now a single bond. Okay, because you saturated it, you add something to it. Where did you add? There and there. What did you add to it? A bromine and a bromine. So here you don't have to follow Markovnikov's rule because it's the same thing that you add. So you will have a Br here and a Br there. Chichi, what is the name of your product?
1,2 dibromopentane.
Well done.
Unfortunately, there's no sweet.
And this is put in the house.
I ask him what is the reaction conditions, and then he said no extra heat added. All right, next one. 1 bromopropane. Pro means 3. So 1, 2, 3. And they say on the first one there's a bromo. And remember, the first one can be on the right or the left hand side because it's 3-dimensional. 1 bromopropane. And then they say it reacts with Boitumelo. What is the name of this thing? Potassium hydroxide. Now, I need you to know that potassium hydroxide is a very strong base. That is something you need to know. It's a very, very strong base. Okay, Tapelo, what type of reaction will this be? Money, the pencil. Huh? Another tender.
Sir.
The money is my money.
No, I asked if there is another tender.
Oh, to clean. No, it was good for nothing.
For pretty much a long time.
Yeah.
This side.
Tapelo, why do you say it's a substitution reaction? Because? Okay. No, because you see, you start with single bonds. Okay. We've done 3 reactions. The first one is oxidation. Can't be oxidation because you don't add oxygen. Then you have substitution and addition. Addition you can only have if you start with a double bond. There's not a double. So far it can only be substitution reaction. Okay? So something must change. Now we said for substitution, the reaction conditions must be mild. We must work softly with it. Okay, so here there's 3 reaction conditions that you need to know. Kananelo, what are those 3 reaction conditions?
I give you one, you skip me.
No, you can give one, but I'll ask you again.
Is one the answer give Ganyo?
Yes. No.
Can you give us one?
Look there in your notes. All 3 are there.
What's the question?
Reaction conditions.
Or like the one here?
No.
No, are you at the substitution?
I'm at the substitution reaction, and I think it's called hydrolysis.
Yeah.
Did I spell this correctly?
Yes.
No, it's a white.
Yo, guys, and I'm recording now. There's a teacher that must write a letter, and she says, "Can you help me with this?" What did she say? She didn't say invitation. She said invigilation of I'm not gonna say. I'm definitely not gonna say, but I was like, yo. She's not new, no. I'm not gonna say, but remember the teachers don't. I come from an English school. I was in English school. I studied in English. My previous school was very English. So my English is not great, but it's not the worst. But some of these teachers, the first time speaking English, the university wasn't English, the school wasn't English. So the first time they speak English is, I'm not going to say, Kananelo. Huh? What was the answer?
For what?
What's the question?
The reaction conditions.
Is it dissolving?
Yes, that's one. So the one is this base must be aqueous. It must be dissolved in water. It can't be pure, then it will burn. So it must be diluted, dissolved in water. What else, Cananelo? You must give me 3. Yes. Huh? Just heat? Mild heat. So be specific. Mild heat. What else? Yes, you must have, you can be more specific. There must be ethanol. The whole thing must be dissolved in ethanol. Alright. So substitution, there must be red lights going off in your head. Like there's reaction conditions. I must work softly. There's a lot of things happening here. Okay, now I must think what will exchange, what will substitute. Now it's obvious that the weird thing will substitute, but with what will it substitute? Bromine, if you look on the periodic table, it's in group 17, it's a halogen. Halogens are -1, their valency. So it must swap with another negative thing. Now potassium is in group 1, it's an alkali metal, so that is +1, and hydroxyl, you must know, is -1. So the bromine that is negative will swap with the negative. Okay, it can't swap with the positive because the negative and the negative will repel each other. They won't attach with one another. Okay, right, so these two, I just want to show these two will swap with one another or substitute. Propane? Propane? Propane?
No, we see this one because
No, there is, because it can be propane 2-ol as well. What is it? No, I know I'm asking the questions like this. Oh, no, or nothing. And Lepelo, your question will be primary, secondary, or tertiary alcohol. With a? Wait. Potassium bromide. Why is it a D, Tsepang? Because there's no oxygens. If there was oxygen, it will be bromide. Hey, get it about that. Wait. When is my birthday?
October 18th.
Yes, well done, Miles. Okay. Lepelo, yes, tell me what a primary, secondary, tertiary alcohol? Why is it a primary alcohol? Yes. Alright, next one.
I see. She's running away from the question.
Yes, she is. Okay, next one. But2-ene. But stands for 4. And on the second one, there's a double bond. But2-ene. I like your confidence, Lepelo. Achtapelo. She didn't even count how many. Okay, Mel's number 2. What type of reaction is this? Two. 15 minutes. It is addition reaction. What type of addition reaction?
The first one.
I think, what do we add? We add H2O. So what is it? When you give yourself water, you what?
Yes, hydration.
Hydration. Sorry, I didn't hear you. Hydration. Okay, right. So what you are going to do is you are going to redraw this that was given. Okay, and we see that there we can add something and there we can add something. Okay, now we are going to add an hydroxyl group and a hydrogen group. There are two different things. It's not like I think the first one, we added the same thing. Then you can put it wherever because it's the same thing. But here's two different things. So we must use a Markovnikov's rule. See, what's that rule again?
Ja, Patricia.
Patricia.
She was making an example about Patricia.
He didn't listen.
Patricia is good, Patricia.
Don't worry, you didn't listen, so it's not going to make sense to you.
It has to do with adding more hydrogen.
Yes.
Yes.
Where does the hydrogen go?
To
the
the
carbon?
carbon with the most hydrogen.
Okay, now let's check. So this is our two options where it can go. This one has one, this one has one. So does it matter? No, it doesn't matter because they both have one. So let's put the hydrogen there and the OH there. Katlego, the name of this product. And then Chichi, primary, secondary or tertiary, and why. And then, Botumelu, the positional isomer of the product. The name of the positional isomer.
And then the second prime.
Wacht. Katlego?
Butane-2-ol.
Yeah, so it's butan-2-ol. Well done, yes?
Secondary.
Why is it a secondary alcohol?
The carbon attached to the OH is attached to two other carbons.
Alright. And then, Botumelu, I'm asking for the name of the positional isomer. So, isomer means same but different. What is different? The position. No? It will be something like butan-2-ol. I'm asking for the name. Okay, Botumelu. Positional isomer means the position of the weird thing must change. Okay, so this is the weird thing. What options do we have? Can it go on the third one? No, because then it's the second one from the right hand side. So it can only go there or there. What will the name be if it goes here? Oh, perfect. So the 1-ol. Butan, 1-ol. Did you know how many to take? You're more than you're 11. Well, Unati's not here. Okay, it's a good letter. It says the school comes out tomorrow at 1.
Why not 12?
Because we have a training after school. Say again?
The school is too much people.
No, it's important that it goes. No, I'm
Well, my parents don't do anything except the money they have. You see, we wasting it now.
Siamo, we cover our side. So if the parents say, we never get communication from the school, we said, we gave. It's your child.
But this concerns me, Mus.
It concerns your parents as well.
They don't fetch me, it concerns me. They don't even know when it's coming.
Siamo, sometimes there is some ladies and their parents are concerned about their well-being after school. Okay, now especially when they're small.
How small?
When you are in high school,
Nobody drinks alcohol in here.
Don't say if
You guys forgot, but when you were in grade 8, your parents were very worried.
Not my parents.
I don't understand.
No, not the men. The parents are fine, but the young ladies. Okay, guys, we're not done yet. Thank you. Tiamo, op je boude.
10 minutes.
Yeah, 10 minutes is a lot. All right. Hello.
Mister.
So just FYI, the grade 11s got their marks back. They did very badly, except for 2 got 95 and 93% for science. No, I know. In term 1, you guys suffered term 1. Oh, no, not in English was. And one of the boys asked, "Ma'am, what can I do to do better?" I said, "How many question papers did you work out?" 3, ma'am. I said, "Okay, right." And the lady, she was standing here, the lady that got 95%, how many did you work out? 42 question papers. Said, there's the difference.
She's clapping me.
No, she's not someone that will lie. 42 is a bit excessive, like not even me. I always tried for 10, maybe 15 question papers. That's good. That's how you get 95%, Apello.
Then the thing is not
You won't know her. No, you won't. It's not someone that's... She's a very quiet girl. You won't know who it is.
I know her.
No, you don't. Alright. You won't know her at all, I promise you. Menai Furi.
It's Afrika's class most.
No, not Menai in grade 12. Alright, okay. So offended. Alright, okay, guys. Alright. Now she also did grade 12 question papers. Okay. Right. But because remember it's Newton's laws. She can do grade 12. Okay. No. Okay, But 1 iron, that tells you it's a triple bond on the first one. Okay, and it reacts with hydrochloric acid. Okay. Capello, what type of reaction is this? It's what? Yeah. Addition. Is it addition? What type of addition reaction? Hydro? This belongs to which halogenation. Okay, and there's no extra energy because it's an addition reaction, so it wants to take place spontaneously. Okay, now here, there's 2 things that can happen. Either it can break all the bonds, so it goes from a triple bond to a single bond, or it can go from a triple bond to a double bond. Okay, so any one of the 2 can happen. I must actually specify in the question. So because we're going to do where all the bonds break, now I want to practice where it goes from a triple to a double bond. So we're going to show that it goes to a double bond here. Okay, I fill in the hydrogens that I had. And then I see we can form a bond here and we can form a bond there. Okay. Now, we are going to add a hydrogen and a halogen, 2 different things. So we must follow Markovnikov's rule. Kananelo, what does his rule say?
You must add
Yes, wacht, you must? See how more? Shh. Kananelo.
You must add hydrogen.
Where? Where must you add the hydrogen? Your option is, you have 2 options. Why? As julle gaan so toe praat, gaan ek Afrikaans praat.
Is it because
While he's thinking, so this holiday I flew a lot, me alone with my boy, but he,
You flew. Aeroplane.
yes, I only understands, ne? So I will call him, I'll say, he will run in the airplane, I'll say, Lucas! Then he won't listen. Letabo! Because that's his Sutu name. Won't listen. Then I'll say, Wena! And then he looks, I say, Claw! And then he comes to me. And the people will just look at me, I'm like, sorry. Claw! Cape Town, Durban, lots.
Man,
No, I'm poor now, I have no money, no sweets.
you
Then why the tub? Why the tub?
His nanny decided it's Letabo.
Then there was what you
But I love Letabo, it's happiness. I like it. Yeah, expected happiness, like it's gonna happen.
Does he also know Sutu?
Yes, almost only Sutu.
How old is he?
Kibatla, Dijo, 1.5.
1.5
He
years.
said, Titi, then it's Metsi. Titi. No, he wants water. Well, no, but he doesn't know that yet. He's 1.5.
Yes.
He pees in his diaper.
And he knows what that is.
Yes. Anyway,
How many days keep down Devon? How many days to stay in the sea?
because the thing will
7 days. The holiday was 2 weeks.
Oh,
So you went to Cape Town for a weekend, there
for a week.
For a week.
because I'm all being
and you came Paris Sunday.
And then you come back to the plus.
I don't live on a place.
So this Paris, the Platteland.
As Platteland naman din.
Cananelo. Hello. Nee. That's why I was telling the story, because we were waiting for you. Not too many. There's the most hydrogens. Okay. Right. So we are going, according to Markovnikov's rule, the hydrogen sits at the carbon with the most hydrogen. So this one has 1 and this one has nothing. Okay. So that is why the hydrogen will go sit there and the chlorine will go sit there. Banele, what is the name? Bute. Bute. Shh.
Y-N-E.
No.
Double bond.
Still wrong. Bute. 1E. Because the double bond is on the first carbon. Okay, so your homework is page 30. Page 30. Oito.
Can you